for number 13, again, we want something to say x equals or y equals. This one already does, it's just backwards. So sometimes people don't realize that right away. It does say y equals. Y equals x plus 3. It's just written backwards. That's not a big deal. That means that instead of y, I will use x plus 3 in the other equation. So let's take this other equation, 3x plus 4, and instead of y equals 7, I'm going to use x plus 3. Do your distributive property with the 4, so keep the 3x alone, plus 4 times x is 4x, 4 times 3 is 12, still equals 7. Like terms, 3x plus 4x is 7x, plus 12 equals 7. Subtract the 12, so 7x equals negative 5. Divide by 7, so x equals negative 5/7. And there's half of our answer right there. So that would be final answer, x comma y. X is negative 5/7. Here's the unfortunate part. Based on what we've talked about so far, I'm supposed to take this answer, plug it into one of the original equations, and work it out to get the other number. Well, if I plug it into the first one, I have to make common denominators to add it with the 3. If I plug it into the second one, I have to multiply, then make common denominators with the 7, then divide everything by 4. Either way, I have to use fractions. There is another option. And I want everyone to follow along with this because some people prefer to do this all the time. Whether it's a fraction or a whole number, you always have this option. Instead of taking this answer and plugging it into one of the originals, you can go back and do substitution again in a different way. I started this problem by saying y equals this. Everyone agrees? Started with y equals. I could rearrange it to make it say x equals. Couldn't I? It'd be pretty easy. Just subtract the 3, right? Let's do that. I'm going to take x plus 3 equals y. And since I already solved for y equals, let's just move the 3 over here. And let's do it for x equals. I'm going to take that second equation. Instead of x, I will use y minus 3. Everything else stays the same. And now I completely avoid using fractions. I will distribute to get 3y minus 9 plus 4y equals 7. I'll combine my like terms. 3y and 4y is 7y. Minus 9 equals 7. Add 9. 7y equals 16. Divide by 7. So y equals 16/7. I solved and got x the first time. I solved and got y the second time. Both answers were fractions, but did I ever actually use fractions? No. So if you do not feel confident and comfortable working with fractions, you always have this option. Is it more work? Yes, absolutely. Which is why people don't usually do it this way. But does it avoid fractions entirely? You bet it does. And if you really want to avoid using fractions because you feel like you make a lot of errors that way, this option is out there. You get the same final answer either way.